Welcome back to this final video on skip patterns. As a reminder, we want to calculate the proportion of women in our sample who had a Pap test in the past 5 years. In a previous lesson, we used conditional processing to create a new variable for our analysis that contained information about whether or not a participant had a Pap test in the past 5 years, including contextual information that could be lost if we didn't properly account for the skip pattern. The final step is to do a quick data check to make sure we didn't miss anything. The overarching idea here is that we want to compare the number of participants with each unique combination of values for the variables affected by the skip pattern to the number of participants in each level of the new variable we created to manage the skip pattern. That may seem confusing, so I'm going to back up and walk you through it step by step. First, take a look at this one-way frequency table for the variable we created, Pap5. There isn't anything new in this code. If it doesn't make sense to you, please review the lesson on descriptive analysis of categorical variables. We can see that 5,912 participants did not have a Pap test in the past 5 years. 16,222 participants did have a Pap test in the past 5 years, and 419,322 participants have a missing value. Next, we take a look at this two-way frequency table of had Pap2 by last Pap2. All we had to do to create this two-way frequency table was add two grouping variables to the group by function. Otherwise, it's the same code we used to create the one-way frequency table. Try not to be thrown off by the fact that the category combinations are in rows instead of a row by column grid. It's just more efficient to display the data in this way when there are a lot of categories, but it's the same counts you would get from a cross tabulation in a grid layout. For example, this first row tells us that there were 8,592 participants who answered yes to had Pap2 and within past year to last Pap2. Now let's quickly compare these two tables to make sure none of our participants are miscategorized. Let's start at the top. Did the participants in this row have a Pap test in the past 5 years? Yes, they reported that they've ever had a Pap test and that it was in the past year. Similarly, these first four rows tell us that 16,222 participants said that they have ever had a Pap test and also said that they've had one in the past 5 years, which is the same number we got in our new variable. So far, so good. Next, we can see that 4,543 participants said that they have had a Pap test, but they had it 5 or more years ago. We can also see that 1,369 participants said that they have never had a Pap test, and therefore, they have also not had a Pap test in the past 5 years. 4,543 plus 1,369 equals 5,912, which matches the number we got in our new variable. Finally, let's take a look at who we haven't classified as a yes or a no in our new variable. These 506 participants reported that they've had a Pap test, but not when the most recent one occurred. Unfortunately, we don't know if their last Pap test was 10 days ago or 10 years ago. Therefore, the only value we can give them for Pap5 is missing. These 162 participants didn't tell us whether they've ever had a Pap test or not. Therefore, we certainly can't say if they've had one in the past 5 years. So, the only value we can give them for Pap5 is missing. Finally, these participants didn't answer either question, so we have no information regarding their Pap test history whatsoever. And again, these numbers all add up to exactly the answer we got. We can now feel confident that we appropriately accounted for the skip pattern. But what would our data check show us if we had failed to correctly account for the skip pattern? Well, the two-way table on the left would look exactly the same. And our calculation for the number of women who had a Pap test in the past 5 years would still be correct. But the number of participants in the other two categories of Pap5 would not match. That should be a big red flag and prompt us to investigate further. Now we can create a simple one-way frequency table to answer our research question. What proportion of women that participated in the 2015 BRFSS have had a Pap test in the past 5 years? The answer is about 73%. Notice that when we fail to account for the skip pattern, as shown in the bottom frequency table, we overestimate the proportion of women who had a Pap test in the past 5 years. Okay, before we wrap up, let's quickly recap what we learned about skip patterns. Your first task is just to identify the skip patterns. Then you must decide if you need to do anything to account for the skip pattern. I suggest you do this by thinking about your research question and the other information available to you in the context of the entire dataset. Once you've decided that you need to account for the skip pattern, you can typically do so using the data management techniques you've learned in this course. Finally, it's always a good idea to do data checks. I've been working with data for many years, and I still catch myself making mistakes all the time during my data checks. So please don't forget to do them. And with that, we've concluded our discussion on skip patterns.